Welcome everyone to Ammonia Energy Live, a monthly series where we explore the wonderful world of ammonia energy and the role it will play in global decarbonisation with an Australian twist. I just want to begin today by acknowledging the traditional custodians of the land on which we meet, and I pay my respects to elders past and present. I'm calling in from Wurundjeri country in Melbourne, and I extend my acknowledgement out to country wherever you're dialing in from around Australia or indeed around the world. And this afternoon, we're visiting Japan, home of IHI Corporation. The use of ammonia for power generation, using coal co-combustion and also in gas turbines is a topic gaining serious momentum as power utilities explore ways to decarbonise their operations. Here in Australia, we've had a front row seat for these Japanese developments in ammonia coal combustion. And we've got a chance today to find out what's happening on the ground in one of the key future destinations for Australian green ammonia exports. Joining us today to explore all this is Toshiyuki Suda, Manager of Corporate Strategy Headquarters at IHI Corporation in Tokyo. He'll be interviewed by Andrew Dickson, Development Manager at the Asian Renewable Energy Hub at CWP Global, and Darren Jarvis, Vice President of Strategic Project at Incitec Pivot. We encourage everyone to submit questions during the webinar via the questions box in your go-to menu. We'll have time at the conversation for some of these chat box questions, and we'll also answer some pre-submitted questions today as well. There's some really good ones. Sending in your questions for the speakers when you register is a really good way of ensuring they get answered, and we've used them to shape our content today. Just a final reminder, all Ammonia Energy Live episodes live over on our YouTube channel. The recording of this will be up later today. Search for Ammonia Energy Live or AEA Australia and make sure you subscribe to our channel once you get there. So without further ado, I will hand it over to Andrew.
Great, thanks Julian. Hello everyone. So Suda-san, thank you very much for joining us from Tokyo. So to kick things off, can you please introduce us to IHI Corporation and where this whole decarbonisation push has come from?
Okay, so thank you very much for the introduction. Good afternoon, everyone. My name is Toshiyuki Suda. I'm from the company named IHI in Japan. So IHI is one of the heavy industry company in Japan, and we have a very wide business field like aerospace, infrastructure like bridges, and also some industrial machinery. And of course, energy is one of our important business field, such as coal-fired power plants and LNG terminal, and also oil refinery. So last October, Prime Minister Suga of Japan has announced that Japan will achieve carbon neutral before 2050. So this announcement had a big impact to the company which is emitting a large amount of greenhouse gas in Japan, such as power company or cement industry or also steel industry. So many of our customers in Japan ask us to propose the best solution to reduce their greenhouse gas emissions. And this is especially, we have a very many, we are asked by many power company in Japan right now, yes.
Thanks very much, Suda-san. It's certainly a big task ahead for IHI to support the decarbonisation of the Japanese industry. So what about you personally? What are your motivations in the decarbonisation space?
Yes, so personally, I have been working more than 20 years for coal combustion research, how to reduce CO2 emission and how to achieve the higher efficiency. And of course, I was proud of my research. But several years ago, when I visited the United States, I had a strong opposition to my research field, to stop the research for the coal. And so I understand that situation around energy has totally changed. So I have changed my research topic totally toward carbon neutral, such as hydrogen, carbon capture utilization and storage, and also renewable energy. So of course, ammonia is right now it's my important topic right now.
So why ammonia, Suda-san? Why is IHI making ammonia such a key focus of its activities?
Mm-hmm. So for Japan, we have to import more than 90% of our primary energy from foreign countries. So of course, at the moment, we rely on fossil fuels such as coal or natural gas. So of course, in order to achieve carbon neutrality, we have to import carbon neutral or carbon-free energy, such as biomass or hydrogen. So of course, all of you know that hydrogen is very difficult to transport. So ammonia is very easy to transport because it is easy to liquefy. And another advantage is that it can be directly used in the power station. So for IHI, we have installed so many coal-fired power plants in the world, like in, of course, in Japan, but also in Australia, United States, and also Southeast Asia. And we know that by ammonia, we can reduce CO2 emission from these power plants with a minimum cost, just changing the burner or something like that. So of course, our user still can use the coal-fired power plant by changing to ammonia, and they can reduce the CO2. So this is why IHI is focusing on ammonia.
Thank you.
Well, Suda-san, we'd better get into all of the exciting R&D activities that IHI has underway. Can you tell us what are the latest developments with coal co-firing, gas turbine R&D, and any other exciting areas of research?
Okay, so for coal firing, we started a project at the Hekinan thermal power station operated by JERA. So JERA is the largest power company in Japan right now. And we are trying to demonstrate 20% ammonia co-firing in 1,000 megawatt boiler in Hekinan power station. So our demonstration operation is planned in 2024 because it takes a little time to make an infrastructure for the ammonia supply. So this project is really important because the demand of ammonia for commercial operation is so huge, such as 500,000 or 600,000 tons per annum, even for 20% co-firing. So we think that this project surely will accelerate the establishment of whole ammonia supply chain. And so also for gas turbine, we have a new technology to use liquefied ammonia directly, so not vaporized ammonia. So we already succeeded 70% co-firing, liquefied ammonia co-firing with our 2 megawatt gas turbine. And we will challenge pure ammonia, 100% firing gas turbine in these several years. So we think that by this technology, we can omit the vaporizer in the system. So the total system for the gas turbine will be really simple. And also, IHI is also developing ammonia-fueled solid oxide fuel cell. So advantage of fuel cell is, that it has a higher efficiency than combustion power plant. And also the heat from fuel cell can be directly used for the ammonia cracking to produce hydrogen for the fuel cell. So we have made a 1 kilowatt small system to check the operation for our solid oxide fuel cell, and now working to scale up to more than 10 to maybe to 100 kilowatt.
Very interesting. Can you tell us a little bit more about the Hekinan project? We've all heard that that's getting underway. Can you just sort of describe more about what's going to happen there over the next few years and what's physically involved with preparing to co-fire ammonia?
Okay, so Hekinan project is a totally 4 years project, and our project's target is to check the performance of boiler and total plant efficiency. So in ammonia co-firing, basically the flame temperature will decrease, so that radiation heat transfer in boiler will decrease. So we assume that boiler efficiency will slightly decrease. But we think that this effect is not so large according to our simulation, CFD, computational fluid dynamics simulation. So our aim is to check the performance finally. So advantage of our technology is that we only have to change the burner for 20% co-firing. So we don't have to change other equipment, only the burner. So however, we have to install ammonia supply unit because right now ammonia is used for SCR unit, but for the fuel, you have to increase the supply flow rate. So we have to install ammonia supply unit, such as a large storage tank and also something like a tube and also the vaporizer.
So I understand, Suda-san, that the installation of this ammonia infrastructure is actually one of the largest activities and the one that takes most of the time. The physical change in the power plant is relatively minor. So from an interesting perspective there, how much higher than 20% co-firing do you think we can go? And how long might it be until we see a 100% ammonia-fired power plant reusing that coal infrastructure?
Okay, so coal co-firing, Japanese government will start to develop technology to co-fire more than 50%. So in coal-fired power plants, so we will start to make a develop to increase much more. So maybe the technology will be ready before 2030, and I'm not sure about the pure 100% ammonia-fired boiler. Because the efficiency for gas turbine is higher than the steam turbine. So I'm not sure I'm not sure that 100% boiler will come. But anyway, government is trying to increase. And for our 2 megawatt gas turbine, we think that we can develop 100% purified gas turbine before 2030. Because it is rather small and very easy to make experiments, so we can make this technology much faster than the coal-fired boiler.
So let's drill further into the gas turbine, Suda-san. So can you tell us a little bit more about the developments and when you think ammonia gas turbines might be commercially ready?
So difficulty of ammonia-fired gas turbine is how to achieve a stable combustion and also to reduce NOx. So if we compare with natural gas, which is usually used for gas turbine, its burning velocity is about 1/5 for ammonia, and also mechanism of NOx formation is totally different. So usually the NOx comes from the nitrogen air, so this is called thermal NOx. But for ammonia, this nitrogen comes from fuel, so it is called fuel NOx, and the mechanism is very different. So from our deep experience on the combustion, we have improved our combustor to achieve stable combustion and also lower NOx emission. So we only changed the combustor of our 2 megawatt gas turbine, and I just mentioned that we have already succeeded 70% co-firing by liquid ammonia directly injection. So our plan is to commercialize 100% pure ammonia 2 megawatt gas turbine at first, and to scale up this technology. So anyway, we still need to check the durability of our gas turbine. So it will need several years for commercialization.
So, Suda-san, let's look ahead to the future. So in the immediate term, what are your views on the best applications for ammonia combustion? And looking ahead maybe 10 years, do you see new developments evolving? And how large a role does ammonia play in power generation in Japan and elsewhere?
Okay, so in Japan, we think the best is to use ammonia for coal-fired power plants because it has a large impact on CO2 reduction, and also in Japan we still use coal-fired power plant, maybe 20 to 30% for our primary energy. So also in Asia, coal-fired power stations still plays an important role for energy supply. So we think the situation is the same. So it's better to use in coal-fired power plant. And for so it is said that the demand of ammonia in 2030 is about 3 million tons per annum in Japan, which is equivalent to 1.2 gigawatt power supply. It's about 1%. So ammonia should be used for other purposes like industry or maritime. So we think that the demand should expand. But the bottleneck will be the time to establish the infrastructure for ammonia. So right now we don't have any large tank for energy use. So we have to make infrastructure before the commercialization. Yeah.
So a follow-up from those predictions, how do you see the development of an ammonia for energy market over the next 10 years? I mean, what are the volumes that you expect to see, blue versus green? And, how would potential suppliers of ammonia, for example, from Australia, interact with with companies like IHI Corporation?
So if we compare blue and green, it is said that blue ammonia is cheaper than green ammonia, and right now Japanese government is saying that they want to distinguish the color at the early stage. So maybe therefore blue ammonia will dominate the market at first. But however, the value of green is higher than blue for the CO2 reduction. So if the hydrogen price from electrolyzer decreases, then the time for green will come earlier. So IHI, right now, we are on the utilization side, and we know the demand of ammonia, and also we can expand our demand. And also we can contribute to construct ammonia production plant in Australia and also elsewhere. So we are very happy to collaborate with the potential supplier for ammonia in the world.
That's great. Great insight, Suda-san. But obviously, it's not going to be simple. The development of the ammonia for energy industry has some challenges. What do you see as the big impediments that still stand in the way of ammonia being widely used as a power generation fuel?
So, of course, first is the price of ammonia. So if you compare the price with coal, it is about 4 to 5 times higher, so very expensive. So right now, there are less incentives to use ammonia for power producer at the moment. So we hope government will think about the support for fuel price. And another issue is infrastructure. So advantage of ammonia is that there are already the technology for ammonia production and also the transportation and storage. But there is no infrastructure right now for energy use. Right now, it's only used for the fertilizer or feedstocks. So we need a significant investment to develop the infrastructure. So this will take time and also money.
Can we talk a little bit more about NOx emissions? You mentioned it in a previous answer. Are you confident that as an industry, we can manage NOx emissions from ammonia combustion? And is there a lot of research going into this area that will give IHI and other players in this industry confidence of managing NOx?
So as I mentioned that I was called commercial researcher. So for the researcher in coal combustion, NOx formation from ammonia is well known because there is a nitrogen in coal and it comes like ammonia and it is oxide to make a NOx. So we know the mechanism very well. So that is why we can develop low NOx combustion technology for coal. And also this technology can be applied to gas turbine. And also we think that we can apply also for other equipment. So of course, we have to improve the technology. So for the gas turbine, CO NOx emission is higher than the natural gas. So, but I believe that we can achieve near zero emission. So please remember that we started the development of using ammonia in power plant from around 2014. So this was called SIP project in Japan. So we came here within only 7 years. So there's a lot of things we still have to do right now. Yeah.
Okay.
That's a lot of difference between that and the many generations we've had working on fossil fuel combustion. So thanks for your insights today, Suda-san. Perhaps there's some last input. I was wondering if you could share what you find valuable about being part of a network like the AEA, and what can the wider AEA network do to help accelerate the uptake for ammonia energy solutions from your perspective?
Okay, so ammonia is the best way if you have to transport or storage carbon neutral or free energy. But still, it is not well known that it can be directly used in power plant like coal power plant or a gas turbine with a less NOx formation. So I hope Ammonia Energy Association would help us to expand that ammonia can be directly used for the power plant and can reduce the CO2 emission. So also worldwide cooperation is necessary to develop the total value chain. So I think that AEA is more on supply side. So it's really important to cooperate with the company like us in the utilization side. So I hope some members in AEA also make some webinar for our consortium in Japan. It is called the Clean Fuel Ammonia Association. We call it the CFA. So, and it's better. We must change the information. Yes.
Thank you, Suda-san. So I thought we might now take some of our pre-submitted audience questions, Suda-san. The first of these is from Nancy Norton, which is, what is the efficiency of using ammonia as a fuel versus hydrogen? And how does this compare to converting ammonia back to hydrogen for fuel use?
So if we compare pure ammonia with cracked ammonia combustion in gas turbine, for the cracking, you need about 15% of heat is needed for cracking. If you compare with lower heating value of ammonia, so efficiency of gas turbine is for electricity, it is about 25%, and also 55% for heat recovery. I mean, there's a heat recovery steam generator at the outlet of the gas turbine. So totally it's about 80%. But if you think about to crack ammonia, you have to use the heat at the outside of the gas turbine, because for the cracking, it's the temperature is about 400 to 50 degrees Celsius for using the catalyst. So you have to use exhaust heat. So this means that the recovery heat recovery from HRSG will be reduced, maybe about 50%. So we think that direct ammonia, so ammonia can be directly used for gas turbine, and we think that we can control the NOx. So I think we don't have to crack ammonia for the gas turbine right now.
Okay, we've got another question from Phil Lukadu from Haynes Boone. His question is, will IHI's ammonia-fueled technology apply only to new combustion turbines or to existing gas turbines?
So our technology, we only have to change the combustor or maybe burner for ammonia firing. For the gas turbine, we don't have to change the compressor or turbine. So can be used for both existing gas turbine and also new gas turbine.
Thanks.
Thank you. Another question from Gonzalo Diaz from Sherpa's Group. What are the most challenging issues nowadays in scaling up the ammonia combustion technology?
So like in Hekinan project, it's a 1,000 megawatts, so very huge. So we have to scale up our burner, and then we have to check that combustion performance, like NOx formation, also flame stability, and so on, with our large scale up burner. So we believe that we think that our concept is okay. So we think that NOx formation does not change in our scaled up burner, but anyway, we have to check it. This is a demonstration, yes.
Okay, next question from Nader Rad from Canexar. Would IHI have willingness to participate in blue ammonia production and all green?
Yes, of course, we have an interest on the production side, because our idea is to first make a huge demand by co-firing in coal-fired boiler in Japan, and then increase the supply and balance the supply and the demand. So also, of course, we would like to participate in the production side, and also so we want to contribute to balance the whole value chain. So the balance is very important. So it's like a chicken and egg. So first we want to make a demand, and then supply, then balance it. That is our idea.
Thank you very much, Suda-san. I think that's been a wonderful contribution today. Julian, do we have any other questions from the audience today?
Just going through, it's been, I'll reiterate to thank everyone for their pre-submitted questions. They've really helped us shape some really good content for today. Going through the audience questions, Suda-san, I'm wondering if IHI is aware of any environmental issues for ammonia storage. Is infrastructure something that you guys are looking at, safe infrastructure and handling?
Yeah, our company already makes ammonia tank. Maybe so right now in Japan we have made a lot of ammonia tank for industrial use and not for the energy. So of course we can contribute to make a infrastructure like a tank and also the receiving terminal. But we must them it takes a lot of investment. So we have to cooperate with other company to make a total infrastructure.
Oh, that's good. I'm sure your expertise in that safe handling and infrastructure is certainly going to pay off down the track. The other questions were about the NOx emissions, which is really good. We've covered a lot of that in the webinar. I think with that, I might wrap up there if that's all right, guys. Thank you very much for your content today. That will wrap up our July episode of Ammonia Energy Live. Thank you very much to our live audience for coming along. A lot of demand for this one. Next month, we're taking a break, but we're not taking a break from Ammonia Energy. The Ammonia Energy Conference 2021 Australia will run as an online event from Wednesday 25th through to Friday 27th of August. We're hosting 7 panel sessions and 30+ speakers, and we'll address all the key topics. So come along to find out the current status of some key clean ammonia export projects in Australia, some new R&D in the ammonia value chain, a fantastic certification discussion, I'll plug that one, and the key next steps for the ammonia energy industry in Australia. You'll hear from some familiar faces. Andrew, Darren, and Suda-san are all going to be presenting in various panels, and you'll hear from some brand new people to the ammonia energy community. I'm thrilled with the speaker lineup, and I'm sure it's going to be a very, very engaging event. So please mark that in your diaries. Wednesday, 25th of August online, starting at 1 p.m. AEST. Everyone who registered for this event will get more information in their inboxes, including how to register for the conference and prices. So thank you very much to Andrew, to Darren, and to Suda-san, and we'll see you next month for our Australia conference. Ammonia Energy Live will return in September. So thank you all very much.
Thank you.
Thank you very much.
Bye-bye.
Thanks, guys.
Bye-bye. Bye-bye.